No.
Empezamos, ¿verdad? Okay. Hello. We are Emma, Maria Andrea, Stefania, and Rafa, and today we are going to talk to you about our key activity results. First of all, we are going to introduce you about the mathematics and the mathematical models. The first question says, how can we use mathematics to analyze real-life phenomena? Well, we think that mathematics is a very useful way to analyze real-life phenomena like scales in earthquakes, climate, natural disasters, or like in this case, the temperature. It helps you to predict or to make a pattern with the results and help you to understand all the situations. And talking more about the models, it helps you to predict. One of the most common ways is talking about the data, because it has like ups and downs that with previous results, you can be more accurate in the future cases.
Now, this is the first function we use in the first graph. In the first and also in the second graph, to get the amplitude, we subtract the highest temperature of 2020 with the lowest of 2019. Then the number of the period, I use it as a sine and then as a cosine. In this case, is a sine. And finally, the displacement, I add the lowest temperature to the amplitude. So here's the graph of the first one. And the second one, I use it with cosine. And this is the graph. It's supposed to be the same, just in different equation. And then the third one, we made a table with all the temperatures, and that's what we got. These are all the temperatures between 2020 and 2019. And at the final one, we did the same, but we add an equation, which is this one, that it's supposed to give us the similar to the first and second graph, but it's not the same. This is the graph, and we have it there with all these points that are the temperatures, and we see that it's similar, but it's not the same as the one that we made.
After analyzing the already plotted data, we found a difference in between them, as my partner already said, that it's supposed to be similar, but not exactly the same, because one curve is lower than the other. And we believe that none of the two models is better, because after analyzing them, we noticed that both models are almost exactly the same, as I already said. And the only difference is that one is more exact than the other one. And according to our research, the temperature of the state goes up and down in an almost continuous motion. And the period represents the exact temperatures that are marked or reported by our source.
Now for the parameter comparisons, we got the value obtained by the team and the value that the graphic software gave us. For the amplitude, the team obtained 3.2, and for the graphic software, 0.65. For the period, we got minus p divided by 2, and the software got 1.91. And last one, the displacement. We got 23.5, and the software 21.35.7.
And then we also got those functions that are what we already see, that it's sine and cosine, and the other one, it's what the software gave us.
And last part are the predictions. According to both models, we decided to figure out which was the temperature during January, February, and March of 2021. For the model obtained by the team, we saw the graphic we made of sine and cosine and look for the number 25 as January, 26 as February, and 27 as March. And we got in January 20.73, February 21.9, and March 23.5. And for the model given by the graphic software, we saw the graphic that the software of Desmos made. And again, we look for the number 25 as January, 26 as February, and 27 as March. And the results were January 20.79, February 20.81, and March 21.35.
Thank you.